All right, so for my online friends watching at home, let's show this again for those guys. Next test is November 12th. For you guys online at home, I've posted the worksheet packet. It's a whole bunch of pages, but it's everything you need for the entire unit. And I labeled them. They're labeled by worksheet, but they're also labeled by date. So if you want to print them out all at once, go for it, but it's quite a few pages. If you want to print them out a few at a time, again, the date is marked on them, so you'll know what day you need which thing. So it may seem overwhelming at first, but again, it's everything you need for the next 2 weeks. So I think you'll be okay, including some notes pages. So today we're going to go over worksheets 1 and 2, but the notes will just be some of the homework off of, or some of the problems off of there. All right, number 2. X to 0 is 1. Power to a power, we multiply. And so, well, let's do one more thing before we start to simplify. What does a negative exponent do? Sends it, I'm not going to say it sends it to the bottom. I mean, that's correct. But a better way to say it is it sends it to the other side. Right? So if it's in the bottom and it's negative, it would flip to the top. So don't think goes to bottom, think flips it over. So in this particular case, it'll send it to the bottom. So let's see how many things we want to do at one time here. X to 0 is 1. Don't have to worry about that. This is going to be y to the negative 6. So that's going to go to the bottom. So y to the 6 in the bottom. Z to the negative 5 will send z to the bottom. And then staying in the bottom will be x to the 5th, y to the 4th, z to the 7th. Uh-oh, nothing's in the top. Right, don't leave it blank. That's one of my favorite all-time answers, is a blank top, because hey, it all canceled, so there's nothing there. Like, well, yes and no. There's something there. Put the 1 up there. Then in the bottom, let's see, I've only got one x term. I got 2 y terms. What do I do with y to the 6th and y to the 4th? Put them together, yes. How do I put them together? What do I do with their exponents? Add them. And then z to the 5th, z to the 7th would be z to the 12th. So hopefully that's a review. It sounds like it was. You guys knew what you're talking about. Let's look at number 7. Looks a little bit worse. We have options. We can distribute the negative 2/3 first, or we could simplify. Excuse me. We could simplify inside first and then do the negative 2/3. I see nodding. I think I agree. Let's simplify as much as we can first before we worry about that fractional negative exponent. 27 and 125, kind of stuck with that. That won't reduce. Let's see, x to the negative 6 would go to the top. I'm trying to save space here, so how many total x's in the top do I have now? 12. And what about y10 and y7? What's that become? y3 on the top. Right? So if they're on the same side, you add them. If they're on different sides, you subtract them, but put them where the bigger one was. You okay? So y cubed in the top. Not that you would need to do this, but the reason is y to the 10th in the top means there's 10 y's up there. 9, 10, I think. Y to the 7th means there's 7 in the bottom. 5, 6, 7. Yep. And so 7 of them will cancel, and 3 of them are left. Like, once in a while, I'll see somebody do that on the test because they forgot the rule and they don't want to miss the problem, so they kind of write it all out. Hopefully you remember the rule and don't need to resort to that, but that's where the rule comes from. So hey, if it comes to that, do what you need to do. Then all of that to the negative 2/3. I think probably the easiest thing is to put that negative 2/3 on all the pieces and then figure out what it means for each individual piece. So 27 to the negative 2/3, 125 to the negative 2/3, x to the 12th to the negative 2/3, y cubed to the negative 2/3. And you now probably see why I picked number 7, because there's a whole bunch of stuff going on there. Negative flips it over, so we could have done that from the get-go. We could have just flipped everybody because of the negative. Do you know how to handle 27 to the 2/3? We've done this. Careful, not divided by 3, but root it 3, third root it. The bottom number is the root, right? The root goes underneath, the flower power goes on top. So we'll root it. We'll third root it. That gets us 3. 3 squared is 9. And it was negative, so that 9 goes in the bottom. That was a lot of stuff at once, but we've done these before, so I think we're okay. 125 to the negative 2/3. So I know it'll flip to the top. The cube root of 125 is 5. All right, we pick these. We work enough of these, you start recognizing the numbers, because there's only so many different numbers we can use that have nice cube roots. 5 squared is 25. Now the exponents are even easier because we said power to a power we multiply. So 12 times 2/3. 12 times 2 is 24. Divided by 3 is 8. Or 2/3 of 12 is 8, either one. And that would flip to the bottom, so x to the 8th. Two-thirds of 3 would be 2. But negative, so it flips to the bottom. So again, that's review, but we hadn't done it in a while, so worthwhile review. Why don't you try 13? You try 13, and then we'll look at it and see what we got. All right, so let's look at that one. What we know what the negative does. What's the negative do? Flip it. In fact, you may want to do that first. Some people say, you know what, let's handle the negative and then we'll worry about the 1/2. Like that last one we sort of did it all at once. If that's too much, we'll back up and just say, well, the negative flips it. Now let's do the 1/2 stuff. So 16 to the 1/2. What's the power of 1/2 mean? Square root. Power is 1, so just the square root of 16 is 4. The square root of 9 is 3. Celebrate if you got it right. Good, lots of celebrations. I hope all celebrations. Okay, so on this page, I want you to do the odds. We're not done yet because we need to get to the graphs. I want you to do the odds on that page. It's mostly review. A lot of them are easy, so that page should go pretty quick. All right, exponential graphs. So page 2 here. I'm trying to figure out how to fit 2 lines of notes without doing it anywhere else. I think we'll just fit it in up here at the top. Here's how we're going to do this. Make a table of values. I mean, that's always a good way to do a graph, especially if you don't know what it looks like, is just start picking some values and plotting points and see what happens. There's nothing wrong with that. And we're going to do that today, but we want to pick our x values, so the exponent becomes -1, 0, and 1. And that's what we're going to call our 3 key points. Looking way ahead, the test for this unit is with calculator and open note. It's like, hey, why don't I just type that in the calculator and draw it in? You can do that, except that it's going to specify that you complete the table of values with the 3 key points. So if all you do is type it in the calculator and sketch a graph, well, you're not going to have the rest of this answered. You won't have a table. And so the calculator can help for sure and kind of verify what you got, but you're still going to need to know what this 3 key points refers to and show those on your table. All right, so let's do number 1. So making a table. Well, sometimes it's easy, because if x is the exponent, then actually, you know what, I'm going to add a third column to my table of values, because I always want my exponent to be -1, 0, and 1. So that column will always be the same. I want the exponent to be -1, 0, and 1. Then I need to figure out, well, what x values would give me -1, 0, and 1. And this one's pretty easy because x is the exponent. So -1, 0, and 1. So table of values, but with a little extra step thrown in to make sure we get the right table of values. All right, so we'll plug in -1. What's 3 to the -1? Three to the -1? Which one? So I heard 1/3 and -3, but it's 1/3 because the negative exponent flips it over. Here's another place where the calculator might help, might not. The calculator is going to have a decimal there, and if you're doing it the way I want you to do it, you'll have 1/3 there. Now 1/3 is easy enough, you'd recognize that decimal, hopefully, and put 1/3. 3 to the 0 would be 1, and 3 to the first would be 3. Transformations, that means like how has it been shifted? That's the parent function stuff. But this is the parent function, so none for this one. This is our parent function that we're trying to learn on. Well, let's graph our points. -1, 1/3 as best we can. 0, 1, 1, 3. You know, for this one only, since it's our first one, let's go one more on either side. So let's do -2 and 2. Again, I'm always going to ask for 3 key points, but since this is the very first one, we may not know what this thing looks like, and 3 points is not very many. What about 3 to the -2? What would that be? So flip it over and square it. 1/9. This gets really hard to graph. Like, how am I supposed to graph 1/9? It's just barely above the... Well, even that's probably more than 1/9, but you get the idea. Plug in 2. 3 squared is 9. We're almost off the graph. Where would we be if we plugged in x equals 3? Yeah, way up there. 3 cubed is 27, so it'd be way up there. So on the bottom end, it looks like we're running into an asymptote here. On the top end, we're shooting way up into the air. when we pick the right 3 key points, we always catch it right at the turn. That's the point of the 3 key points. Because if you pick 3 points to the left, then it looks like some straight line down here. If you pick 3 points to the right, then you're way, way off the graph. And so we always want those 3 key points. Right? Find domain, range, and asymptotes. So domain, that's the x values. So that's left and right. So what values of x are allowed here? What values of x does the graph cover? Yeah, all of them. That's the good answer. Infinite, all of them. So negative infinity to infinity. It covers all of them. The range is the y values. It's not all of them. Something to 0, almost 0 and up. And we get closer and closer to 0, but we don't equal 0. So that sounds like a parentheses at 0, because we don't get there. We just get closer and closer to there. Speaking of getting closer and closer but not getting there, that sounds like the definition of an asymptote. We get closer and closer to 0, but it needs to be y equals 0. You don't have to graph it, but if it helps you to see it, then you certainly may. The big thing on the graphs is the 3 key points, the 3 points that make the exponent be -1, 0, and 1, because that will capture the turn just perfectly. Otherwise, you get some almost vertical piece or some almost horizontal piece, and your graph doesn't make much sense. So if you'll catch the 3 key points, then you'll have a good graph, and I think with a good graph, you're able to answer the questions pretty easily. Let's do number 2. Basically, we're just going to see how many we can get before the bell rings. So exponent x and y. Again, first column is always going to be the same. I want my exponent to be -1, 0, and 1. That way I'll catch it right at the turn, and my graph will be a good one. So what value, it takes a little bit of thinking here, what value of x would make the exponent be -1? 1. Because 1 minus 2 is -1. I mean, you can set this up as an equation, but most of these are simple enough. You kind of just think about them. What value of x would I need to make the exponent be 0? 2. And then what value of x would I need to make the exponent be 1? 3, because 3 minus 2 would be 1. And then kind of a bonus here is when you go to plug in x, you've already got what the exponent is, because you've kind of rigged the problem to work in your favor. So if I plug in 1, I'm going to get 3 to the -1. That's 1/3. If I plug in 2, I get 3 to the 0. Anything to the 0 is 1. If I plug in 3, I get 3 to the 1st, which is 3. Why don't you see if you can graph those points and fill out domain, range, and asymptote, and then we'll check and see how we're doing. This might seem silly, but one of the dangers here with this third column is, that's not the x or the y column, so don't use those points. I mean, those are the exponents, those are important helpers, but the points are still the x and the y. So over 1 up 1/3, over 2 up 1, over 3 up 3. Oops, over 2 up 1. Let's put that in the right spot there. Now, that's only 3 points, but we know the general shape now, so we're okay with 3 points. If you want more than 3 points, you're welcome to extend your table in either direction, and then really get the full turn in there. But I think 3 points captures what's going on. I remember the next one's all the way up at 9. So again, it makes a sharp turn. When it turns quick. Let's see. Domain is the x values. Range is the y values. What x values does this cover? All of them. The range, it's kind of like last one. It looks like it gets almost to 0. Almost to 0 meaning parentheses, because we don't get to 0. And then it shoots way up, so 0 to infinity. And speaking of almost to 0, our asymptote would be y equals 0. Questions on that one? All right, yeah. Oh, yes, thank you. So we kind of took care of the transformation already, because we do so there's two ways to graph them. You can label the transformations first and then move the graph around. But if you take care of the key points thing, that sort of takes care of the transformations. But it asks for it. X minus 2, all the transformation rules are the same. So if it's x minus 2, that should mean we move to the right 2. And yeah, that's what happened. If you compare graph 2 to graph 1 over there, it's shifted to the right by 2. So some people will save that to the end and use it to verify. Other people will answer it right off the bat and kind of help that guide their process here. So like number 3, what's the transformation for that one going to be? Up to. But then we don't really use that because we use the key point thing. Exponent x and y. Again, exponent is always -1, 0, and 1. Why don't you try this one, start to finish, and then we'll compare notes and see what we got. So the exponent is just x, so figuring out what the exponent needs to be is another easy one. Just -1, 0, and 1. So 3 to the -1 is a third, but plus 2. Oh, I'm still frozen on that. There we go. So 1/3 plus 2, well, let's just leave that as 2 and 1/3, because that'll make the graphing easier, because I don't want to change that to, well, that'd be 7/3, but that doesn't help me with the graph, so I just leave it as 2 and 1/3. I plug in 0, 3 to the 0 is 1, plus 2 is 3. I plug in 1, 3 to the first is 3, plus 2 is 5. So let's graph them. Again, be careful, although I guess it wouldn't matter on this one. The exponent stuff is the helping stuff, but the graphing stuff has got to be the x and y pieces. So -1, 2 and 1/3. 0, 3, and 1, 5. Okay, here's where we need to be careful, especially about where that asymptote is, because we moved it up a little bit. In fact, maybe that writing that up 2 helps. When we make the turn, we're not going to go all the way down. We're going to stop at 2. So domain covers all the x's. Anybody ready to make a conjecture or a hypothesis or a guess about what the domain is for all of these? All of them. The domain is always all real numbers for exponents. You can plug in anything you want to an exponent. So I don't want to say it's a dumb question. The answer is always the same for domain. Range is where we got to be a little bit careful, because it comes down, but it stops. It almost gets to 2. and goes up from there. So 2 to infinity. Again, range and asymptote kind of go together. We said almost gets to 2. That sure sounds like an asymptote thing going on. You may not realize this yet, but that number that's out there by itself is always going to be the asymptote. So that's a bit of a shortcut that you don't really need because you can figure it out. But when you've done enough of these, you start to realize, wait a minute, I know what the asymptote is going to be even before I start the problem. And sometimes that can be helpful. Let's do number 4. We got a 2 out front. What's the 2 do in terms of transformations? Good. Vertical stretch. Vertical stretch times 2, and then that plus 1 is up 1. Now the order you do this stuff in doesn't matter to me, so some of you may be jumping ahead and thinking, well, that means I definitely know what the domain is, and because of that little shortcut, I may know what the asymptote is. And so maybe you start to realize, you know what, let's jump ahead a little bit, because it might help when it comes to the graph. So I know y equals 1 is going to be the asymptote. Let's just see if we can kind of confirm that. Exponent x and y. Exponent is always -1, 0, and 1. Oh, this is another easy one. X is the exponent, so -1, 0, and 1. I plug in -1. I get 1/3 times 2 is 2/3 plus 1 is 1 2/3. Plug in 0. Okay, be careful. 0, sometimes we get to thinking that 0 just wipes stuff out. Like, well, not really here. 3 to the 0 is 1 times 2 is 2 plus 1 is 3. There's not much room to show that, but if you need to off to the side, show that work, you can do that. I don't think you would need to show all of those steps, but show the steps that you need to show. And then if x is 1, 3 the first is 3 times 2 is 6 plus 1 is 7. So we got a few bigger numbers here, but that's expected because of this stretch by 2 and moving it up 1. So -1, 1 2/3, 0, 3, 1, 7. Well, that looks stretched out compared to my others, but that's the whole point. We stretched it out compared to the others.
Could the range always be the asymptote, infinity?
Not quite. Okay, the question was, is the range always asymptote to infinity? If it's flipped over, then it would be -infinity up to the asymptote. So you're almost right. For the normal ones, yeah, it's from asymptote up. But if we have a negative x in there, we don't on the first page. I wonder if we do on the second page. We don't. Well, wait a minute. On number 6. Number 6 has a negative out front. So that would flip the whole graph over. So it's going to be, the range will be -infinity up to the asymptote. So good observation and almost exactly right. Speaking of asymptotes, labeling the asymptote is sometimes helpful, especially on these ones that get stretched, because sometimes you can't tell exactly where that turn happens. But we already know the asymptote's at 1, so we can go ahead and graph it with that in mind. almost out of room for domain, but we know what domain is always for these. And the range would be from 1 to infinity. Okay. Jonathan, your question is still a good one and still thinking about it. The asymptote always sets one of the boundaries for the range. We could phrase it like that. If it's flipped over, then it's the upper boundary. If it's normal, it's the bottom boundary. But you're right that it does set one of the sort of endpoints of the range. Having said that, let's skip to number 6, since that one's got a negative on it. And our exponent's a little different. So exponent x, y. Guess we could do the transformations first. Minus 1 is right 1. What's the minus sign out front do to the graph? Flips it. So this is definitely going to be different. Can you tell what the asymptote's going to be even before we start the problem? Remember, it's the number that's out here after all of this stuff. 0. There's not a number out there. So it's going to be 0. All right, if I want my exponent to be negative 1, what does x need to be? What does x need to be so that the exponent is negative 1? No one wants to talk, maybe because we're recording. Yeah, 0. 0 minus 1 would be negative 1. 1 minus 1 would be 0. 2 minus 1 would give us 1. We don't really go this deep into it, but you can also kind of tell by the table the right one is sort of reflected in the table if you're really watching what's happening there. I guess just to keep it consistent, the pink column's always the same. Okay, a little bit of PEMDAS here. Exponent comes before multiplication, and that negative out front is multiplication. So 3 to the negative 1 is 1/3. Then put the negative on. So negative 1/3. We plug in 1, we get 3 to the 0, which is 1, and then put the negative on. So negative 1. If we plug in 2, the exponent's 1. 3 to the first is 3. Then put the negative on. Negative 3. Again, with the 3 key points, we should capture the turn, although I guess it turns differently this time. 0, negative 1/3, 1, negative 1, 2, negative 3. So this looks different than the others, but that was expected. We said it flipped. Domain's still the same. Range. What's the range? In the correct order, what's the range? From what to what? Good. From negative infinity up to 0. Sometimes people reverse those because they're like looking at it and their brain is thinking it goes from 0 to negative infinity. Yes, but we always have to put the smaller number first. So negative infinity up to 0. And yet again, as always, that asymptote sets a bound on the range. Sometimes it's the upper bound, sometimes it's the lower bound, depending on if we flipped or not. All right, so we've done 5 of the 12. So your assignment is to finish the worksheet. So worksheet 1 is the odds, and worksheet 2 is all, but we've done half of them already. I would just caution you, all the examples we did were with 3. The base was 3. On the back, careful, the base switches to 2 and then even to 4. So everything's still the same, it's just don't get stuck in the the 3 and the 1/3 and the 9 stuff because we switched to 2 and 4.